Graph the piecewise function below. Use the graph and the function to fill in the following information. So the function f is defined by 3 different pieces. Okay, here -7 to 1, -7 to 1, 1 through 3, and here 3, x is bigger than 3, so 3 and all the way. So we can make that here x fx for the first piece, x fx second piece, x fx third piece. Look at the second, the function is always 2 in this interval, so 1 is not included, but I'm going to include that 1 and a circle. Okay, there is 1 not included in this domain. So at 1, that's 2. At 2, because 1 through 3, right, 2, the function is always 2. At 3, also 2, so 3 is inclusive. For the first piece, -7 to 1, so -7 is not included, so I'm going to put a circle, and we go all the way to, let's say, to where? Up to 1. 1 is not included either, so I'm going to put circle. So -7, let's plug in here, -7, so we're going to plug these values here in this piece. So -7 plus 2, -5, absolute value of -5 is 5, 5 minus 1, 4, so that will be 4. Let's go maybe -4, x -4, so -4 plus 2, -2, absolute value of -2 is just 2, 2 minus 1 is 1. Let's do -2, -2 plus 2 is 0, so just 0 minus 1. In fact, you can take more values, okay, this is not necessary, you go in this way, -2, then let's say 0, so 0 plus 2 is 2, absolute value of 2 is 2, minus 1, just 1, 0 and 1, okay. For 1, which is not in the domain, but let's do it anyways, 1 plus 2, 3, minus 1, 2. In the same way, third, we got third piece here, that's 3 through all the way, so 3 is not included, but I'm gonna plug in anyways. At 3, 3 minus 3 is 0, square root of 0 is 0, and all the way, let's plug in couple of, maybe 3, then I don't know, maybe 5, 5 minus 3, 2 is square root of 2, oh, that's square root of 2 is about 1.4. And let's go 7, 3, 5, 7, etc. 7 minus 3, 4, square root of 4 is 2. So I chose 7 so that we could do this, and this should be enough. Okay, now let's plug these values here. So the first is -7, 4, so -7 is here. At -7 we got 4, okay, but that's circle, that's not exactly in this graph. -7, 4, then -4, 1, -4, 1 here, so this is a straight line, because you know when we have this absolute value function, so it's just a V shaped graph, okay, so 2 straight lines. Then -4, 1, -2, -1, so -2, -1, so here, then 0, 1, 1, 2, so 0, 1, 1, 2, that's not in the graph, but I'm going to put circle. So we got a V shaped graph, should be straight, then go up, okay. You can do better than this, straight lines. Then now that's the first part of the graph. Second, 1, 2, 3, always 2, okay, 1, 2, always 2, right, always 2. So for 2, that's 2, for 3 also 2, but 3 is not included. Oh, never mind, 3 is included, okay, 3, 2, so 3 is included. So it's not circle, it will be dot. Included means dot. So we have this graph. Then the third piece is square root function. We know a square root function is something like this. It's just the shift. -3 inside means shift 3 units to the right. So 3 0, not in the graph, but we can put a circle. 3 0, 3 0. So 3 0 is here. So 3 0. So we put a circle. Okay, it's here 3 0. Then 5 1.4 7 2. 5 1.4, I don't know, somewhere here. And then 7 2. 7 2. So this will be just something like this. It keeps going forever, because the third is 3 through all the way. Okay, so we have this piecewise defined function. So this is circle, by the way, dot, sorry, and the circle has a circle, has a circle. Now we need to answer a couple of questions. Determine the domain of f. I mean, this is the function. It starts at -7 here, -7, and we have graph all the way to here, which is 1. I mean, there is no value. -7 to 1, union, then goes 1 through 3. There is a value 3. Then after 3 we have this piece picked up all the way. So in fact after 1 is everything, because 1 is not included, 3 is included because of this dot, and after 3 this graph, the third graph, picks up everything. That's the domain. Locate any intercepts. Look at this graph. This graph intersects this y-axis at 0 1. So y-intercept, okay, y-intercept is 0 1. Now there is no value. Oh, x-intercept here. Okay, I didn't do the good job, but this graph was supposed to go through here. That we can check. In fact, this is -3. At -3, the graph value will be 0. At -3, I did not evaluate, but if we plug in -3 here, -3 plus 2, -1, absolute value of -1 is 1, 1 minus 1, 0. So -3, 0 in fact. If you had drawn this straight, you would see this is -3, 0. That's the x-intercept. -3, 0. Okay. Next, use the graph to find the range. Range means we start from smaller and go up, like on y-axis. So the smallest value the graph can assume is here. There is a value, that's -1. Okay, so -1, that's inclusive, and up, it can go up to 4 not included, but this piece is going forever, slowly increasing. So when x grows to infinity, this one grows to infinity as well, slowly going all the way to infinity. So infinity. Okay, graph the piecewise function below. Use the graph and the function to fill the following information. So our function f is given by 2 pieces: x cube, cubic curve, x plus 4, which is a straight line. So x cube when x is less than 0. Less than 0 means up to 0 all the way to -infinity. So on this domain, the function has the shape of cubic polynomial x cube. And from here, starting 0, 0 is not included, and all the way to 5, up to 5, the function has x plus 4, which is degree 1, means straight line. This is x cube. By the way, this is cubic function, and we are just graphing on the left side, this portion, just the left portion, something like this. And on the right side, up to 0 to 5, we have this piece. So we're going to find some order pairs and go from there. So x, fx, x fx. For the first domain, we got a lot of values, negative infinity through 0. I don't know, maybe let's take like negative 2, maybe negative 3, negative 2, negative 1, and 0. 0 is not included, so I'm going to put circle next to it at 0. Let's evaluate. It's a cubic, right? So negative 3 means negative 3 cube. Negative 3 raised to 3. That's negative 27. Negative 2 cube, negative 8. And negative 1, this is 1. Negative 1, 0, 0. Okay, in the same way, I mean, this one is too much. Negative 27, we don't have room down here. Okay, so we're gonna disregard that. We have room up to negative 10. For the second, we got x plus 4, 0 to 5. So I'm going to put 0, though 0 is not in the graph. So I'm going to put next to circle, next to circle. This is not on the graph, but we need to take reference of this. So at 0, this is the function, right? 0 plus 4, 4. At 1, 1 plus 4, 5. At 2, 2 plus 4, 6. And it goes all the way to 5. Okay, 5 plus 4, 9. So let's look at these points here. For the first piece, negative 3, negative 27, we don't have grid that long, so let's ignore this part. Negative 2, okay, negative 2, negative 8, negative 2, negative 8. So negative 2, negative 8 is here. Okay, negative 1, negative 1. So negative 1, negative 1 is here. And 0, 0, that's just the circle. That's not on the graph, but we can take reference of that. Now let's connect this. It's a curve, so it will be, okay, it should go to negative 1, 1. Okay, this is not good. So something like this one, and don't do a straight line. This is curve, okay? It goes in this way, like this. My bad, it just keeps going in this way. Okay, just the curve. That's the left side. Now right side, 0, 4. That's not on the graph, but we can look at that. 0, 4, starting here. 0, 4, 1, 5, 2, 6. 1, 5, 2, 6, 5, 9, all the way to 5, 9. That's the highest point. 5, 9, and it's a straight line, so we just connect them. Okay, so we have two pieces. It's a cubic on the left and straight line on the right. Now the questions are, determine the domain. So domain means x values. Look, this one is going forever. Forever means negative infinity through 0 is not included. Look, here's a circle, circle. So 0, we have to exclude 0. Then 0 to is 5, and it stops at 5. Bracket. Okay, we can check that. If we go up here, it's up to 5. So negative infinity is 0, union 0, 5. 0 is not included in either of the curves. Okay, that's the domain. Now any intercepts. Look, this graph does not intersect x-axis because we have circle, and this graph does not intersect y-axis either, so none. No x-intercept, no y-intercept. Now we need to find the range. Range means, look, smallest is going forever, so forever means negative infinity through up to almost 0. There is no 0 value though, so 0 is not in the range. Okay, not only 0, then we don't have 0, and these values are all skipped and picks up 4. 4 is not included, all the way to 9. Union 4 is not included, 9 that is included because we have dot, so up to 9. So these values are skipped, but we have all the way negative infinity through 0, 0 not included, and starting 4 all the way to 9, 4 is not included. Final.